there. Welcome back to New Scientist Weekly, your curated selection of the week's science stories. I'm Chelsea White in Portland, Oregon.
And I'm Christy Taylor in New York. This week, a close look at the COVID-era explosion of telehealth startups in the United States and the complications they bring to meeting a real need in healthcare. Plus how weather is shaping the fall and rise of insect populations, a little reptile with a big moo, and some real estate advice for anyone looking to get cozy on the moon.
But first up, we've got new measurements of the behavior of antimatter, specifically how it behaves under gravity. And while regular matter reliably falls down when under the influence of a gravitational pull, well, it turns out so does antimatter. Alex Wilkins is here with more. Hey, Alex.
Hey.
So should we be surprised that antimatter doesn't fall up or react in some other way that's different from regular matter?
So I don't think surprising is exactly the word. According to quantum mechanics, which is our best theory of how very, very small things work and move, there should be this thing called antimatter, which is the counterpart to regular matter, apart from one small difference. It has an opposite electric charge. So protons have antiprotons, which are negatively charged, and electrons have positrons, which are positively charged. And we also have Albert Einstein's theories of relativity, which you might have heard of. And they also say that massive particles, which antimatter particles should be, in that they have mass, should move through space in the same way under gravity. Now, the problem is that this has been a very difficult behavior to actually measure. Antimatter and its opposite particle will mutually annihilate whenever they meet. And because there's so little antimatter in the universe, it's almost all matter. Whenever we produce antimatter, it will just pop out of existence almost as soon as we make it. So it's been really hard to produce and store enough antimatter to actually test whether it does move through space like matter, as Einstein said it should.
Yeah, I'll bet. I mean, so how do you come up with enough of it to get this data?
Well, you need to go to a very specific place, which is the CERN particle physics laboratory in Switzerland. Researchers there have been building and sort of coming up with all these facilities to make antimatter for the past 20, 30 years. And they've made a new experiment called Alpha G, which is this series of vertically stacked chambers where they can produce and store antihydrogen and then test whether it basically falls down. It's a really complicated process. They use these incredibly strong magnets to encapsulate the antihydrogen. And at the top and the bottom of the chamber, there are basically these seals in magnetic form. But once they release those magnets, they can then measure how the atoms fall under gravity.
Okay, so they set up a complicated apparatus, as you described, and they managed to make some antimatter stick around long enough to measure. So what happened?
So once they'd made the antimatter, they had about 100 antimatter atoms at a time in the trap. They then released it by releasing these magnetic bounds on the top and the bottom. And they basically just waited to see where the antimatter atoms go. Now, because these antimatter atoms, even though they're cooled to incredibly cold temperatures, they still have some energy. So some of the atoms will escape out the top and some will escape out the bottom. But hopefully, because of gravity, there'll be more atoms coming out the bottom than the top. And that's exactly what they found. They found this disproportionate number of anti-hydrogen atoms coming out the bottom than the top, which indicates that gravity is influencing their movement.
That's really cool. So now that we have this kind of proof of concept, is there anything to indicate that the antimatter was behaving in any way differently, like even a little bit, from the regular conventional hydrogen?
So I think we need to wait a little bit longer before we can say that there might be some difference in the way gravity is affecting them. The researchers were able to measure the influence of gravity based on the speed the atoms were falling, and they did find that it was going down towards the Earth, which is what we expected. But the range in which it varied, as opposed to sort of what we measure regular gravity, is between 0.46 and 1.04 times what normal hydrogen acts under, or G, which is what we call the rate of gravitational acceleration. It's not the most precise measurement. They just wanted to get the direction of it. But now they're going to be sort of, with future experiments, trying to get this number tighter and tighter to see whether it is in any way different from the gravitational acceleration that normal matter experiences.
Since the start of the COVID-19 pandemic, it feels like I can't get through a single TV show or take public transit without encountering an ad about telemedicine. But how well do virtual healthcare appointments serve the needs of patients with acute or chronic health needs? Joining us from the New York office is our health reporter, Grace Wade, to discuss the influx of telehealth startups and how they shape up to traditional in-person doctor appointments. Hey there, Grace.
Hello. Thanks for having me back on the pod.
Okay, so let's maybe start by providing some context, especially for our listeners who are not in the US right now.
Right. So telemedicine, which is the ability to meet with doctors virtually, has existed for decades. But it wasn't really common until the COVID-19 pandemic. That's because, as we can all remember, people were looking for an alternative to in-person doctor's appointments in an effort to keep COVID cases low. Around this time, the U.S. government also eased up restrictions on needing face-to-face consultations to get certain prescription medications. The result was a lot of demand for telemedicine appointments, which left room for telehealth startups like Hims and Hers, Ro, and Cerebral to fill the gap. So I looked into how these work. They're not like the telehealth services offered by a doctor's office. They're direct-to-consumer startups that actually act like a middleman, connecting people with doctors or therapists who work as contractors. They also aggressively advertise on social media and streaming platforms.
Yeah, exactly. Those were the ads I was talking about earlier. They always make it seem so easy to get treatment for so many different conditions like depression and hair loss and erectile dysfunction, which I find just kind of suspicious, actually, given how much of a hassle getting even basic preventative care can be sometimes.
Yeah, I've noticed those ads in my feeds too. It seems kind of concerning to me, I guess, at first blush, to cut out the regular doctor's office. And I've also found myself wondering if these companies are preying on people in vulnerable positions. But, I can see the appeal, particularly for conditions that people might feel embarrassed about or who don't have the means or the energy to set up a traditional doctor's visit.
Yeah, that promise of convenience is really what makes these telehealth startups stand out compared to other telemedicine services. Obviously, each company differs slightly, but generally they work by drawing people to their website through advertising. From there, people can set up an account and fill out a short health questionnaire before scheduling an online appointment with a licensed healthcare professional. After talking with the patient either through a live video call or via chat, these doctors can and often do prescribe medications which are delivered directly to people's doors.
So you don't have to see a doctor in person at all to get these medications.
That's right, and that certainly has its advantages. I mean, for one, it cuts down on the time it takes to travel to a doctor's office or the pharmacy. That's great for everyone, but especially for people who live in rural areas or who have wonky work schedules.
Yeah, true. I mean, it does sound great in terms of accessibility, but there are downsides too, right?
Yeah, quite a few actually. For one, there are privacy concerns. A joint investigation into 50 direct-to-consumer telemedicine companies in the US by the news websites Stat and The Markup found that all but one had allowed big tech companies like Google and Facebook to collect consumers' data. Most of these companies say they have resolved or are working to resolve these issues, but the findings highlight a real issue, which is that telehealth startups aren't always subject to formal regulation. Since they merely connect consumers with providers, they aren't regulated by certain laws that protect people's sensitive health information. That means consumers' browsing history or potentially even the initial health assessment aren't guaranteed to be confidential.
Yikes.
And that's not all. The rapid rise of these telehealth startups sometimes leads to people being wrongfully prescribed unnecessary medications. Last year, the U.S. Drug Enforcement Administration found that a pharmacy for multiple telehealth startups was wrongfully filling thousands of prescriptions for controlled stimulants like Adderall.
Wow. So it seems like cutting corners then for the sake of convenience can come at the expense of safe and quality care. And I know also that the U.S. Food and Drug Administration has even blamed shortages of drugs like Adderall on telehealth over prescribing. I mean, I have several friends who are struggling with their access right now.
Yep, I mean, that's me too. That's why some experts are calling for more stringent regulations on these companies, because at the end of the day, they aren't going anywhere, and they shouldn't necessarily have to. They still fill a critical role in healthcare, but healthcare experts want to see them do so in a way that is subject to privacy laws and other regulations that ensure quality in other care settings.
Every week, we bring you some of the most fascinating news in science, medicine, and technology. But on our Culture Lab podcast, we also go deep on some equally fascinating ideas, like climate change, conversations about which can too often succumb to doom and despair. Thankfully, we've got just the thing for that coming next week. A conversation with paleoclimatologist and activist Michael Mann, who wants to remind us that there's still a great deal we can decide about the habitability of our planet.
You'll often hear climate doomists. They don't deny climate change. They deny we can do anything about it. So we're all going to be extinguished. All life on Earth will be extinguished in a matter of a decade or so, no matter what we do. it doesn't stand up to scrutiny, what's happening today.
That's coming up next Tuesday, right here in the New Scientist podcast feed.
And after all that, maybe you're still hungry to learn about the latest scientific discoveries, ideas, and innovations. The Royal Institution's exciting autumn season of public science talks is now open for booking. Based in the heart of London, the RI has been a home for science for over 200 years. This season sees pioneers such as Carlo Rovelli inspire audiences with the latest from the leading edge of science. Listen and learn about the wonders of our planet and beyond. Uncover the truth about artificial intelligence in the legendary RI Christmas Lectures, which comes this year from Professor Mike Wooldridge. The Royal Institution is an independent charity in the heart of London, creating opportunities for the public and scientists to explore science together. The RI is a home for science, and everyone is welcome. Book now at rigb.org.
Next, we head to Europe, where researchers have a new answer in the debate about what is driving insect declines on the continent. Environment reporter James Deneen is here. James, what's going on?
Yeah, so you might have read some stories a few years ago talking about a so-called insect apocalypse with widespread declines in insect populations in many parts of the world, and with those, the threat of widespread insect extinctions.
Yeah, I remember those headlines. It was really alarming, sort of apocalyptic sounding even.
Well, part of what really started this alarm among researchers stemmed from this study that was conducted in Germany in 2017 that found a pretty shocking 76% decline in flying insect biomass, which is the weight of all the insects flying around in protected areas there between 1989 and 2016. And that finding was especially concerning because researchers weren't really sure what was behind this decline. Was it a loss of habitat due to agriculture or cities, or maybe it was pesticides? Was it climate change? How much of this decline depended on the species of insect, and so on?
Yeah, and those are all a lot of very valid questions, which seems like it would take a lot of research to answer. A lot going on, basically.
There is. And researchers have had trouble getting to the bottom of it. For instance, one study that followed this 2017 paper found that there is actually not a difference in insect numbers between agricultural areas and more natural areas, which complicated the theory that loss of habitat was the main driver. And of course, this has led to lots of debate. But now a group of researchers have proposed another idea, which is that the weather is the major factor behind these booms and busts of Europe's insect populations. To do this, they used data on insect populations in Germany from the 1980s all the way up to 2022 and showed that statistical models that considered the weather could explain the changes in insect biomass better than models that didn't. But in some ways, even more impressively, they found they could predict the levels of insect biomass in different areas of Germany in specific years, only using data about weather in the region. And the researchers told me this is strong evidence weather is a major factor for Europe's insects.
So when we're talking about weather being bad for insects or causing their populations to decline, what are we talking about? What kinds of weather patterns are affecting insect populations?
Well, in lots of different ways, weather can affect different parts of insect life cycles. For instance, when the eggs get laid, when they hatch, metamorphosis, all of this. But different combinations of good and bad seasons lead to complex results. For instance, warmer, drier winters had a negative effect, according to this new research, but warmer, earlier, wetter springs had a positive influence.
So there's a lot going on here, but it sounds like, is the debate settled?
Definitely not.
Yeah. Sounds a little too complicated for that.
Yeah, still pretty heated. I spoke with an author of that original 2017 study that found the massive declines in Germany, and he said he thought this new result about weather was, quote, too good to be true. He said he found it unimaginable that weather alone could explain the dramatic declines measured among Europe's insects. And he said he still has to look under the hood of this new study to understand what's going on, but he's not convinced yet. And another important caveat to mention here, this study looked only at biomass, which measures all flying insects together, both common ones, pests, rare ones. So the story for particular insects may be quite different from the overall story.
But if it does turn out to be weather and not habitat, what do we do? isn't that the one thing we can do like the least about?
Yeah, it's a good question. I put this to a researcher named Eliza Grames, who studies insect declines at Binghamton University in New York. And she said that the first thing she takes from this new link between weather and insect populations is it's another reason to move faster to cut greenhouse gas emissions to slow climate change. But she also points out that insects are really adaptable and respond well to microhabitats. She said for an insect, the top and bottom of the same leaf are different temperatures. So even relatively simple things like increasing the complexity of habitats can do a lot to create refuges for diverse insect species. So there are things that can be done for sure to conserve insect biodiversity.
For Life Form of the Week, freelancer Sophia Quaglia is here. Welcome back, Sophia.
Hiya, thank you for having me.
I heard you have a new critter to add to the list of animals that moo?
Yeah, take a listen to this and tell me what you think it is.
Okay, I'm going to need to hear that again. Just one more time. It sounds like a very large cow, no?
That's not a cow. That is an African dwarf crocodile, the world's smallest living crocodile, at just under 2 meters long. And that's not the only sound it can make. Actually, it can also make drums, rumbles, and a gust at really low frequencies that are hard for humans to hear.
Wow.
I just have an important announcement to make. I have looked up the African dwarf crocodile, and they're really cute. And clearly this little one has a lot to say. But Sophia, there has to be a reason you've been listening to crocodile conversations.
Fair question. Let me explain. African dwarf crocodiles have big eyes and tiny bodies, the perfect recipe for cute. Agreed. And they can be found in West Africa. I say can be found, but they're actually really hard to find because they prowl the dense forest and the narrow streams and know well to stay out of the human sight. We know that they must be quite common because they're sold on the bushmeat market quite a lot. But that also means they mustn't be doing too well if they're hunted this much. So scientists in Poland think we should be monitoring their populations remotely by monitoring their sounds. The fact is, before this, they didn't even really know what these crocodiles sounded like.
All right, so I'm guessing someone had to go and make an inventory of the sounds they do make, that they know that they make, before going out to record and count them in the wild. Is that what happened?
Yeah, exactly. So the team recorded 2 captive African dwarf crocs from a zoo in the UK to create a collection of almost 100 vocal signals, and then compared them to more than 200 sounds from the wild that had been accidentally collected for an unrelated elephant conservation project in Gabon, and were suspected to be African dwarf crocs. They were mystery sounds. It turns out the sounds match and can be split into 4 categories of sounds that no other crocodile is known to make. The rumble, the drum, the gust, and again, that moo.
So these are the only reptiles that can moo?
The researchers suspect there might be a Chinese alligator that does something similar, but they still need to confirm these findings. But both the Polish team and other experts I spoke to external to this research mentioned that it's actually totally possible that other species drum or moo like these ones, but nobody has really been going out around recording them to this degree of detail yet. That's why we need a lot more research on the topic in general. We need to see studies to see whether recording crocodiles can be a good, sustainable population monitoring tool in the wild for the long run, whether it works for several different species or maybe just for this one, and whether it can help tell crocodiles apart from one another, and all of these little details. So there's more research to do on this project.
And it's not quite time to go yet. There's always more news than we have time to dig into. For example, Chelsea, if you were looking to build a moon base anytime soon, we can now tell you where to start investing in real estate.
I'm assuming the where is the moon?
Yeah, but not everywhere on the moon is created equal. The South Pole is actually the most attractive spot by far because it has both spots with permanent, constant sunlight, but also these craters with permanent shadows, meaning you could both run solar panels for energy, but also you have these sources of ice for water and fuel. So the question has always been more about which crater might have how much ice and where exactly you would want to locate this hypothetical base. So now a team at the University of Atacama in Chile has synthesized all the data out there on 5 of the moon's southern craters. Slope angles, sunlight, water ice distribution, and so on. And based on criteria like potential power sources, how easy it is to communicate with the Earth, they picked a spot that they think will be the ideal base.
All very important, makes sense. So which crater is the lucky one?
The number one recommendation is actually an area that straddles 2 craters, collectively called Sverdrup-Hensen. It's relatively flat. It has, again, those areas of perma-sunlight for power and plenty of ice and minerals in nearby shadowed areas. All of that said, though, other researchers think we still need more on-the-ground data from upcoming missions on the surface, as opposed to remote sensing, to tell us what conditions will actually be like and where, again, this hypothetical base should actually be put.
I'm guessing all the remote sensing in the world can't really tell you what it's like to drive a buggy on the moon.
Yeah, I think it would be bumpy pretty much no matter where you go, but yeah.
Okay, next story. New research is helping answer the hard questions of who's a good dog.
That's easy. They're all good dogs. I thought that was obvious, Chelsea.
Yeah, they are, but especially therapy dogs used in schools, according to a team in Australia. They surveyed more than 100 educators and school-based professionals about the benefits they saw from having trained dogs supporting students. In general, they found the dog's presence beneficial for lots of reasons, but most importantly because the dogs offer non-judgmental companionship to students who may be vulnerable to bullying or other kinds of social stigma.
That's really sweet and lovely to hear about. Does it seem to matter how the dogs are what jobs they're doing in the classroom, for example? Do they just sit in the back of the room, or are the students interacting with them?
Well, in some cases, students who struggle to read are given a chance to read aloud to the dogs, which seems to help because they know the dog won't judge them for making mistakes. And in other cases, the dogs might help students regulate their emotions just by being well-trained, friendly dogs. And for students whose behavior may be inappropriate for the classroom setting, dogs can offer gentle and, again, non-judgmental feedback.
It's really nice to hear about a study where something that seems intuitively good is actually getting affirmation and data. Dogs helping kids. It all sounds good.
It does.
All right, one last story. Do you ever wonder, Chelsea, why carrots are orange?
This sounds like either a joke or a fable, like how the leopard got its spots. I guess I sort of always assumed it was the pigment from the alpha and beta carotenes, the carotenoids, the chemical pigments named for carrots.
Yeah, that's technically the correct answer. But carrots also had to evolve for this trait. The first domestic carrots started out purple and yellow back in the 10th century, like those fancy rainbow carrots you might see at the grocery store. But ironically, orange carrots are the newer invention. They debuted in Europe in the 1400s. And they've gotten so popular in the last 500 years, partly because of that bright color, but also because they're sweeter than the originals. Plus, it also didn't hurt that we found out that orange carrots juice has some medical benefits.
I mean, I do love a ready source of vitamin A.
So do I. So what we now know, thanks to a team at North Carolina State University, they have sequenced the genes of hundreds of types of carrots of several different colors: orange, purple, white, yellow. And they've uncovered the genes behind the orange pigment that keep orange carrots so rich in those, again, carotenoids that you mentioned. It turns out if you want an orange carrot, you actually need to make sure that 3 specific genes are always turned off. In the other carrot colors, at least one of those 3 genes was turned on. And coincidentally, a lot of orange carrots also have genes selected that delay flowering, which would explain the sweetness, since flowering usually makes a root tougher and inedible.
So the farmers happen to be selecting the best carrots for health and flavor over centuries of breeding. Delicious. That's it for this week. Thank you so much for listening. You can find all the great journalism we talked about today in the show notes. And you can subscribe to this podcast on whichever app you're listening on.
And as always, if you like the great stories we're bringing you, from the serious to the silly to the please give us a rating or review on Spotify and Apple Podcasts. It helps the algorithm share our work with even more listeners, and it makes us feel pretty good too. We'll be back next week. Bye for now.
Bye.
This podcast is produced by OG Podcasts. Find out more at ogpodcasts.co.uk.